Hello, it's me again. I'm Nafid. In this part of the training of ClearPass configuration, which is a continuation of what we started in previous training videos, the focus of this part will be wired authentication. So we'll look at what settings or what kind of security access control can be done on the port. Plus, we will delve into the wired enforcement ClearPass, also what ClearPass can do for us. Now, also the integration of SNMP between the NAT device, which is the switch, as well as if there's non-AAA ports, i.e. some devices connect to the interface and they do not attempt to perform AAA authentication or any form of authentication, can we control? Wild port profiling, so when users connect and perform .1x authentication, for example, how can we understand who is connected and so on. Then we'll delve into the user roles, the two types, local and downloadable user roles. Then after that, we'll touch on user-based tunneling. Let's have a look. So when we talk about securing your network or securing the edge, we are referring this to as wired port access control or access security. Now, you have multiple options. You might leave it open, so no security whatsoever, which is not the best option. You might have to perform MAC authentication, so based on the MAC address and so on. Now, that is a possibility, and most likely in this case, you will resort to MAC authentication if that is the only authentication method supported by the device, something like printers, IoT devices, and so on. Or you might have MAC authentication augmented with another form of authentication, possibly. Now, Captive Portal is another option. Mainly speaking, we might want to implement this one for BYOD or sometimes for contractors, guests, so we can give limited access somehow, and then we redirect them to a web authentication server, and then they might go be able to access some resources, or maybe just go to the internet. And the best option is, if you can, and if the device support that, then we can go for 802.1x. So in 802.1x, we call this one layer 2 authentication. Layer 2 authentication, meaning the MAC authentication and the .1x authentication. And in this case, or these two cases, the client will not pick up an IP till it is authenticated. So they will perform layer 2 communication in those two cases, and they will only be able to communicate with any IP-based communication once they get authenticated. Captive Portal can be seen or can be defined as a layer 3 authentication, meaning the client or the user or the device will pick up an IP before, and then they will be redirected to a page, and then they will be able to perform authentication. If you look at this, definitely this is the least secure, which you don't want, and that's a bad practice, and that's the most secure. Combination between different authentication methods is, yes, definitely a possibility, and sometimes you have to do it that way. Some implementation of Captive Portal, you have to augment this one with MAC authentication. So that's the way things sometimes work. And again, it's not the focal point of this training, but it's quite possible to combine .1x authentication and MAC authentication, common practice. And by default, our switches, CX switches, for example, perform .1x authentication first. If no supplicant that performs .1x, they will resort to MAC authentication. So you can have it as a backup authentication method. Or in the Captive Portal case, MAC authentication is required as part of the Captive Portal process. Again, this is outside the scope of this video, but it is just to show you it is possible to combine both of these or multiple authentication methods on one interface. Now we talk about the wired enforcement. What we mean by that definition. Wired enforcement is, or enforcement, because multiple actions can be taken or multiple instructions can be sent in the accept message. are or is the action or what actions can be performed on the switch once the user authenticates or once we need to just send instructions by SNMP. So we can do things like access control list or dynamic access control list that will be available as long as that connection is available. Dynamic VLAN, so VLAN can be, of course, each interface on the switch will be assigned to a VLAN. We call that static VLAN. But during that connection, when the authentication, say, succeeds or fails, a certain VLAN we can push to that switch interface. We call that one dynamic VLAN. So the running status of that switch interface will be mapped to that VLAN. We call it dynamic VLAN. Or we can send out some other attributes. We call them either as an IETF, which is generic ones that supported or that are supported by different vendors, or a vendor specific attribute that are very specific to that very specific vendor. And sometimes it depends on what kind of device you're talking about. The VSA might be different. And for that to work, and remember the wired enforcement is part of what's so called wired service. So inside ClearPass, for all of that to work, we will need to configure wired service. So if you look into the enforcement profile, again, in the context of ClearPass, as we have explained before, the action or actions are called enforcement profiles. So there we go. The client connects physically, try to authenticate. That request will be sent to a AAA server. In our case, is the ClearPass. That's the focus. So authentication request will be sent. Now, access accept message that is sent from ClearPass back to the switch, and that's part of the response. And that response has instructions to the switch what to do. So they might have radius-based action like IETF attribute, VLAN assignment, vendor-specific attribute, or might be downloadable action, i.e., for example, they support a robot downloadable role, which we will talk about later, user role, or Cisco, for example, if that NAT device was a Cisco device, that then will be Cisco downloadable access control list. Another possibility is, again, part of the actions can be taken or instructed to the switch is SNMP, Simple Network Management Protocol. This is when you integrate the switch and you communicate with SNMP, can set the VLAN ID, session timeout, reset connection, and so on. An example, if would like to just think about access control list, it has what's so called access control entries. These are, and each one of them is numbered. These are just to show you just an example of what access control list might look like. And in here, just a fictitious list, I call it my list. And these are the access control entries in that access control list. Another example is dynamic VLAN. So basically, if you can look into this, we give example of 3 different types of users. One user is a human resources from a desktop. Another is an engineer. Another is a contractor. The 3 of them connect. The 3 of them, each one of them attempts to authenticate. Of course, that authentication request is sent by the switch to the ClearPass. ClearPass then, based on the settings on the ClearPass and based on the context of each one of these connections, they will send back what's so-called AVP, attribute value pair. Things like a VLAN, like in this case, I would like to assign a dynamic VLAN. So the attribute value pair will indicate that is a VLAN to be assigned. Detail with the VLAN, they will say, okay, for that user, who is the contractor, will need to go to the internet only, and I would like to assign them to VLAN 20, and this might be the default gateway firewall for that contractor that takes them to the internet. An engineer, they might want to go and on VLAN 40 as per our settings, and that VLAN 40 might have some sort of access control list. It's quite possible. And then engineering server, maybe some sort of AutoCAD or Revit or whatever, simulation server. And human resources, like in this example, we have assigned VLAN 50 and we allow them to go to ERP system. Now it's quite possible, I mean the whole concept here is you might have all of these switch interfaces by default on one VLAN. Maybe there's a dead end VLAN, we call it 99 for example, or 999 or whatever VLAN number. And then these are assigned port to those to one or multiple VLANs statically and dynamically, as long as the connection still is still there, that VLAN or those VLANs will be assigned. The minute the user stops connected, i.e. the connection disconnected, connection or the port becomes, i.e. the condition like human resource engineer contractor go away, then these ports with the dynamic VLANs will disappear and they will go to the statically assigned VLAN on that port. And that's the term, hence we call it dynamic VLAN or dynamic assignment of the VLAN. The next one would be the vendor specific attributes. So in ClearPass itself, remember ClearPass is the NAC device or network access control, AAA server. In ClearPass, we support virtually all devices, all device vendors that are RADIUS compliant or IETF compliant. Now each vendor, they might have their own what's called VSA. And in ClearPass, this is done through what's called dictionaries. Now, to access dictionary, you go administration under dictionaries RADIUS, and you can see other dictionaries. Obviously, we focus on this one. Now, in here, you can see this screen, and you can see most of those are disabled. There's nothing to worry about because when you add your NAT device, the vendor name, whatever, say 3Com or Adva or whatever, they will be enabled. So by default, they have enabled a bunch of them, and we can always manually enable any one of them. That's not our focus point. Now, we would like to see what VSA. So if you click on Aruba now, you will find they have their own VSA. They have their own VSA. Now, these are only specific to Aruba devices. And if you try to apply these to any vendor non-Aruba, that will be rejected. Will be like an error message if you look at the log on that device or unknown attribute being sent and so on. This is what's called VSA, or these are VSAs, vendor specific attributes. On the other hand, there's something called IETF. Now, IETF are generic attributes that are sent. Like in this case, I would like to show you an Aruba switching terminate session IETF, and these are the list of things can be sent to the switch to perform certain tasks. Notice these are RADIUS IETF. Also, the other thing another way that you or ClearPass can communicate with these NAD or switches, NAD devices, is through what's called SNMP. Now, SNMP, you might want to send instructions to i.e. take action. We call it SNMP enforcement on that device. But to be able to do that, you have to integrate the device, i.e. the NAT device, the switch in this case, and ClearPass. And when you add the device, one of the tabs we call SNMP write settings, so should be able to write back. And here one of the settings is SNMP version 2, or you can go version 3 if you would like. In this case, we go version 2. Now that is to integrate ClearPass with that NAT device using SNMP. So when you send instructions using SNMP message, then the switch will listen to these instructions. Obviously, that will have to match whatever settings that are on the switch. Then once you are able to integrate that, in the enforcement profile, this is the list of actions. You will go with the template SNMP based enforcement. There are multiple types of enforcement, and assume that is what we have selected. And if you go to the attribute tab, you will see what action or actions can be taken, and i.e. instructions that can be sent to the switch. In here we have 3 settings. VLAN ID, and we say this is 10, and I just wanted to show you some other, other two settings that you can send using SNMP to the switch. This means you can communicate, to the switch, or the communication between ClearPass and the switch using SNMP settings. For all of that to work, obviously, we need to enable what's so-called, or we need to create what's so-called wired service. As we have seen before in previous videos, that for the wireless, we enable wireless, for the wired, we enable wired, and I just created this one, just an extremely simple one, and that's extremely generic. So we went to 802.1x wired, even though I did call it Aruba wired 802.1x. In reality, this is extremely generic because these two are IETF attribute. These two conditions for this service to be applicable are applicable to any wired authentication from any vendor, because we have not specified anything to do with Aruba here. Now we talk about the client profiling and non-AAA. So what we mean by this, when you connect, remember this is 802.1x, that's the main focus here. And in 802.1x, when they start connecting, this is layer 2 authentication. So when the client starts in the frame to request DHCP, that will not be allowed. So there's no layer 3 access yet, because that's a layer 2 authentication. So if you look at some details, obviously you can read documentation about this. Only EAP traffic, extensible authentication protocol, can be sent. We call this one uncontrolled ports, which is the port that are, or the ports that are related to .1x authentication. So that request will be sent for authentication. No profile data, definitely, because there's no layer 3 authentication or communication yet. Once authentication happens, and the ClearPass will send what's so-called access accept message to the NAT device, which is the switch in this case. Now that switch will then allow the client that is connected to it to pick up an IP, and if there's any need to browse HTTP, then that will be allowed surely. So now the client will have, after this stage, will have an IP DNS default gateway. This means the client is able to send traffic and communicate and receive traffic. Now, obviously, some details are not shown here. You will have had configured the profiling using DHCP on the NAT device, including that ClearPass as a destination. Plus anything to do with HTTP. So when the client bring up the HTTP web page, then we call it HTTP agent will tell what is that device and some details. And DHCP also would be used, and some other profiling information if need be, if it has been configured. The bottom line is the client is able to communicate with the ClearPass. ClearPass, we might even have what's so-called OnGuard. We'll cover this one later on. OnGuard, that's again another agent that can also send information to ClearPass. When profiling happens, this might lead, again, we're not showing it here, this might lead because initially when the client connected, ClearPass has no idea what that client is. They might place the client maybe in restricted, if you like, privilege, just to allow the client enough privilege to pick up an IP, DNS, reachability, as well as ClearPass reachability and some other destinations. Once that limited access has been allowed, then ClearPass will be able to profile the device. Once that profiling happens, then the ClearPass, based on the policy, again, that all depends on the policy. Based on the policy, ClearPass might send a change of authorization to the client, to the switch, that will disconnect the client and reconnect the client again. So the client will try to reconnect. In this case, ClearPass will have enough information about the device, and they will place them in the correct VLAN and with the correct privilege. Now, when it comes to the non-AAA port, meaning the port that is not attempting to perform authentication, maybe that is any device that is not able to do .1x or MAC authentication. So what happens really when the switch discovers a connection from that device, and the fact we have already integrated these two using SNMP, and SNMP, either version 2 or version 3, notification will be sent to ClearPass. ClearPass will be able to profile the endpoint. Again, remember, the endpoint in this case is not restricted. It has already picked up an IP address. So the endpoint will be profiled by ClearPass. Again, maybe the initial access was restricted, and maybe a COA or change of authorization message is needed to bounce the port. With that message, obviously, will be sent to the timestamp, and then the switch will deal with that. So they will be able to bounce the device, and this also might lead to a device, again, depends on the policy, might be assigned to different VLAN. And that's in the case of non-AAA port connection. The next concept we would like to talk about is user roles. Now, this is really important concept. Now, user roles can be defined or can be classified as either local user role defined on the switch itself, or downloadable user role that will be downloaded, i.e. pushed by ClearPass, and details of that role will be requested by the switch. So ClearPass will send all settings about that user role, and logically, once the device disconnects, that downloadable user role will go away. So what is a rebel user role? If you read the definition of that, it's a set of predefined access privilege, like assign VLAN, maybe assign certain firewall role, certain restrictions, and so on. And that's how you can dynamically, based on the condition of the connection, you can always assign different roles based on different conditions. So for example, in this example, we can see a client tries to perform .1x authentication, and you might have local user role configured on the switch, or you might be sent by ClearPass a downloadable user role that is not configured on the switch whatsoever. And that will be communicated by ClearPass. Obviously, details, as you would expect, switch will send authentication request to ClearPass. ClearPass then, assuming every single setup has been performed, communication is fine, then access accept message, part of that one will be assigning the user role. That user role can either be locally defined, and remember, if it is locally defined, means I have to do it on all switches, or it can be downloaded by the ClearPass, pushed to the switch with all details. Now, if you think about it, if you look into logical view of what happens here, a device connects to the switch, that is maybe a PC. Another device connects to the switch, in this case is a phone, IP phone. They both authenticate, ClearPass or any third party. Remember, this is local user role. It means we don't really specifically need ClearPass. Can be any third party or any radius is able to send instructions back what to do to that client connection. So here that will be, or those roles will be sent as part of also called, in this case, vendor specific attribute. And then we will assign part of the role assignment, because that is locally defined. You will have defined the role on the switch. And part of that role config would be what VLAN does the user need to be in. So in this case, VLAN 30 will be for the IP phone, and VLAN 40 in this example will be for the PC. And then these are dynamically assigned basically. If these disconnect, then these VLAN assignments will go away, and they will be returned to the statically assigned or defined VLAN on these interfaces. That is in the case of local user role. In the case of the downloaded user role or downloadable user role, DUR, we can only push this if we only use ClearPass. So ClearPass is definitely a requirement. No roles assigned or created on any of these switches. The roles are defined on ClearPass with all settings, including the VLAN, security, and so on. And these roles will be pushed to the devices, i.e. to the switches in this case. Now, for that to work, there are some certain requirements. I'll explain the high-level requirements. On ClearPass, you will have to create what's called Aruba user role privileged admin, and that will be used on the switch. Of course, once you go to the configuration details, you will notice that admin account need to be used here. Plus, you need to make sure that there's a trust relationship between the switch and the ClearPass, and the reason for that, the NAT device will use SSL tunnel user certificate and the certificate on ClearPass itself. So for that to work, they need to trust the CA, i.e. certificate authority, that has signed ClearPass on the switch itself. That CA can be ClearPass itself because, as we have seen before, ClearPass by itself can be self-signed certificate and generate self-signed certificate. So it has to be trusted by the switch. Details, of course, can be seen on the documentation, but I do have video on that. Plus, you need to make sure the time is synchronized, because in the case of time problem, because there's a time skew, i.e. Permitted allowed or permitted time difference between the ClearPass and the switch. As best practice, obviously, they all need to talk to one NTP or multiple for redundancy purpose. But again, they need to reference one NTP or some NTP reference in here. Now, within the ClearPass can send the role, obviously, to a switch. But also at the same time, the ClearPass can send roles to mobility controller. And these might contain some policies, user attributes. Again, these are the settings can either be defined locally on the local user role. And in mobility controller, we have also called roles. Again, these are firewall roles, mainly speaking. And then also they have some policies and user roles. Now, if you need to push, again, the focus here is downloadable user role. You need to configure that one or these roles on the actual ClearPass. Now, in ClearPass itself, you go to the enforcement and under the profiles or enforcement profile, you will add a user role and that will be pushed to the device. So it could be pushed to mobility controller, that is where the tunneling will be terminated. It could be pushed to Aruba OS switch, which is kind of a legacy switches if you like. And there are certain settings that can be performed. It can be pushed to a CX switch. Again, there are a few other settings as you scroll down the page. So again, in a nutshell, simply speaking, Aruba supports what's so-called locally defined roles. We call them local user role or downloadable user role that can be pushed from ClearPass to the switch in this case. Now the last section, or this section, talks about dynamic segmentation. So the term dynamic segmentation means I'm establishing tunnels, basically. So this term is more generic than just user-based tunneling. In dynamic segmentation, you can either have what's so-called distributed dynamic segmentation, and this term is referring simply for VXLAN, using EVPN, Ethernet VPN, and VXLAN, and outside the scope of this training, simply you have edge switches and you establish tunnels between them, and we call this one dynamic segmentation or distributed tunneling or distributed dynamic segmentation. That's not the focus of this video, but I want to mention this for you to be able to understand and distinguish between distributed dynamic segmentation and centralized, which is the focal point of this video. So centralized dynamic segmentation, it means, again, it's simply a tunnel, but it's a little bit more than that. Now the tunnel can be either from a switch, which is the focus of this video, or it can be from an access point. Access point, traditionally, they use they form tunnel or tunnels to the controller or to the gateway. And then we have the ClearPass that will be able to send instructions what to do. Right. So while tunneling, you are able to improve security, have centralized policy. So basically, you are pushing the firewall policy from centralized location, which is basically a gateway or a mobility controller. Yeah. Useful, especially in the case of IoT devices. So when the device connects, you don't want to traverse the network, then be inspected by a firewall like Palo Alto or some other company. You don't want that. You would rather have tunneled that traffic to the mobility controller or to the gateway, then perform inspections on that. So apply the uniform policies. You also are able to either do local bridging, yeah. So maybe in this case we might decide the IP phone should be bridged locally. That's fine. And the reason for that probably because we don't want to have a tunnel, even though delay is extremely non-noticeable. But again, you might want to prefer to have local communication. You can also perform load balance, so high availability and so on and so forth. So now, if we take a specific case of the dynamic segmentation centralized, we're talking about user-based tunneling from the switch to the gateway, which is controllers basically. So either version 10, which we call them gateways, or version 8, we call them controllers. The tunnel will be established between the access point, the switch and the controllers, and we can allow or disallow going to certain destination for different connections based on the policies that we apply here. So centralized policy, I can dynamically assign VLANs and some other settings, and this is a much tighter control and being able to centrally manage connections, push the policies, make changes without any major issues if any change is needed to be made. But that's how that works basically. So the user connects, so client connects physically to the switch. The switch will send authentication request to ClearPass, business as usual, there's no problem. And then ClearPass will authenticate. Now we know from previous slides that we are, or the ClearPass will be able to assign a role per device. Again, these are, either downloadable user role or local user role. And if the role indicates tunnel, meaning it depends on the role setup, either on the ClearPass in the case of downloadable user role, or the role that will be configured on the switch in the case of local user role. It might indicate tunnel, go and form a tunnel. So tunnel will be formed, and then we will apply the firewall role on the gateway or on the controller, mobility controller. So the tunnel is there, traffic will use the tunnel, they will go to the controller, i.e. mobility controller, that is a firewall settings. We will be able to assign settings as per our configuration, apply additional security policies based on what we have configured it. So let's look at some details about the communication between the mobility controller or the gateway and the switch. So what will happen again, the endpoint will connect to the switch. That's a CX switch or AOS-S switch. We have what's called two types of tunnels in this case. We call it control plane tunnel, which is PAPI tunnel, and it's well known in Aruba UDP, which is the same form of control plane that is used in the case of access point as well. So UDP port 8211, obviously this port has to be allowed if there's any firewall. So that's control plane tunnel, and they will form what's called data plane tunnel, which is a GRE tunnel. Fine. And the destination for that tunnel will be the IP address of the mobility controller or the gateway. In there, you will configure what's called transit VLAN, which is the VLAN that you will tell, in this case 100. This is the VLAN that tells the gateway or the mobility controller to assign to the traffic from the user. So in this case, this endpoint will be assigned VLAN 100, unless inside the gateway or inside the controller, the role has, or the firewall role that will be assigned to that connection has VLAN assignment that override the transit VLAN that has been instructed by the switch to the mobility gateway. So each switch, we call it tunnel node. One of the conditions or requirements is to enable jumper frame between, the switch and the gateway or the mobility controller. Plus, if there are any firewall, then you have to enable GRE0, and that's protocol 47 for the GRE traffic to be formed. Again, we are not showing you details of GRE header and trailer. You can look at that one at your own time. As well as for the PAPI, again, we need to enable PAPI UDP 8211. Now, for the switches, they don't support IPsec encryption for the PAPI tunnel. You would expect UDP, it's a UDP, so no encryption for the PAPI by default. You can apply what's so-called MD5 encryption or HMAC. So MD5 header will encrypt the traffic for the control plane to make it more secure in case some other switch try to attack your communication. In the same time, we are also able to support redundancy. So you might have a case, again, you have multiple users here, and we are performing user-based tunneling, where we have a cluster of gateways or cluster of controllers. Now we will provide in this case, the primary controller IP, maybe this one, and the backup controller IP, maybe the other one. Now there will be 2 GRE tunnels, one per interface, one per connected device. So user B will have the green tunnel, user A will have the blue tunnel. And here, in between them, they will have load balance. So they're going to assign an active switch access controller or anchor controller. They will assign active user anchor controller for user A. That will be the standby anchor control for user B. And then vice versa for the B for the other user. That will be standby for the switch, active for user B, standby for user A. Load balance. If one of them fail, obviously, how it works, they will be in between them, they will communicate. If 8 missed heartbeats, that is sent every 1 second from primary, we attempt to contact MC through the standby or the backup will attempt to contact the and the switch as well at the same time. Then there will be established a tunnel to the other mobility controller. What is not shown here, indeed, there will be backup. So they will be in standby mode, if you like, backup tunnels and so on and so forth. That's a high level overview of the communication and the tunnels that are formed between the switch or the NAT device we call tunneled node. If you deploy and the mobility controllers, just maybe one point worth mentioning. If you deploy this one on mobility controllers version 8, then each switch, not port, will only consume one license, one AP license, one BIF, one RFP license. If you have a stack of multiple switches, like if you have 6200 version or 2930 or 6300, then you have VSF stack. If the whole stack will be seen as one unit from license perspective. So the stack also will only consume one AP license, one PIF license, and one RFP license. So the switch is licensed per switch, not per interfaces. And that makes it really cheaper in this case. And that's basically what I wanted to cover in terms of wired authentication between access devices, which are in this case switches, and the ClearPass itself.